Welcome, everyone. So, I hope you are having a great time at the conference. It's kind of like a pretty early morning in San Francisco here, so bear with me for a few things. So, let's get it started. So, today we are going to talk about Internet of Things or threats. We really need to understand what exactly it is all about. We're going to look into the IoT bots and how botnets are designed. We're going to focus primarily on some of the tactics and techniques these IoT bots use, and of course the botnet operators deploy those techniques. And we're also going to look at a few demos breaking down internally into the IoT botnet C&C panels. So let's get it started then. So little disclaimer. So all the research and interesting information that we are going to share during the course of this talk is only for community purposes, which means that we're going to strengthen the threat hunting efforts, intelligence efforts, and all those, making sure that we make our security community more secure and more collaborative in nature. A little brief background of mine. I've been into this industry for 14 years right now, authored a couple of books, so you get an idea what we are going to discuss today. We know about that topic. And if you're really interested in looking at my background, what it is all about, you can go to a few URLs here and get an idea what it is all about. So what are we going to talk today? We're going to look into IoT threats. If you look around, looking at the internet hemisphere, IoT devices are deployed and configured all across the internet, various networks. And attackers are utilizing these devices because of insecure characteristics and inherent security issues, maybe vulnerabilities, misconfigurations, and all that, and how they actually exploit them. Of course, using an automated way, because botnets at the end of the day is a collection of compromised machines. In this case, when we talk about IoT botnets, it's more focused on compromised IoT devices. And we're going to take a look into multiple IoT C&C panels that we discovered during the course of this research. And that actually highlights you, and you will get an idea how exactly these panels look like. It might be different from the standard botnets because of the different communication protocol being used, but you will have an interesting idea by encountering this thing via live demo. So let's understand where in which world we are living right now. Of course, IoT threats. So these are a couple of media headlines I have put up here so that you can get an idea how severe the problem is. Just imagine billions of people all across the globe using this internet. And to support that internet functionalities, we really need hardware devices. Of course, we are moving towards cloud, but at the end of the day, still there are data centers, there are chips, there are IoT devices that are allowing this functionality to flourish. But of course, we are living in the world where cybercrime is increasing at an exponential rate. And of course, attackers are going to target these IoT devices as well. And that is, I would say, in their terms, it's a need of the hour, because they want to utilize the free hardware that are sitting on the internet, not secure, and they want to exploit those devices and harness the power of those devices. And the idea is to just conduct nefarious operations on the internet to make sure they achieve what they want to. The overall perspective here is that this is a very, very deep and a very, very interesting problem that, as a security researchers, practitioners, we really need to look into, and making sure what advancements we can make to actually circumvent these IoT threats. In order to do that, we really need to understand how these bots are designed and operated. In this case, for the next 7 to 10 minutes, we are going to look into some of the IoT bots attacks and mechanisms, including different characteristics. It is very important to understand how these devices are getting exploited, what techniques these IoT attackers are using to conduct these unauthorized operations. Let's take a look into it. So what we are going to look into in this context is distribution of IoT binaries. Of course, how the IoT binaries are distributed across the internet. We're going to look at some of the characteristics, like why camouflage IoT binaries are used, obfuscation being placed, exploits embedded in those IoT binaries. Interesting self-deletion capabilities. Of course, executing mass scans, distributed denial of service attacks. And at the end, how these IoT bots are actually utilizing the inherent system tools to trigger the execution of various exploits or unauthorized operations on the operating system itself. Any device running Linux, Unix, or any flavor of it, at the end of the day, you really need to control the operating system from the user level to the kernel level to ensure you conduct, you operate, and trigger those kind of functionalities which IoT bots need. In order to do that, they really need to be on that system, exploit a vulnerability, for example, a privilege escalation and all that. So we'll take a look into that as well. So let's move forward with this. The very first thing I want to talk about here is the distribution of IoT binaries. A couple of screenshots added here give you the idea. One of the interesting scenario that we have seen all across is setting up of an exposed web server on the internet. It can either be on the cloud infrastructure, or it can be either on a compromised servers, data centers, sort of things like that. And they simply deploy a web server which is unauthenticated, and they just host the resources on that server for a short period of time, so that when the malware is distributed and the payloads are executed on the IoT devices, they actually contact these web servers. Of course, since no authentication, no authorization, you can simply connect them either by wget tool or curl tool, and then fetch the resources on the compromised IoT device. And the idea in this case is that, since everything is compromised in here, the web resources are openly available on the internet, and you can connect it, and then you can download those additional payloads and start executing those payloads on the compromised IoT device. And that is one of the important part we really need to understand, because that's the place where infection starts. So distribution of IoT binaries is an important part, and as a part of the research, we really need to conduct scans, build intelligence to fetch where exactly these binaries are located, supporting multi-architecture, depending on which architecture certain devices support. Another interesting artifact that I want to call here is the use of camouflaged names. So let's say you have this web resource, which you are seeing in the screenshot, and it's like exposed on the internet. Of course, it has to be. But if you look at the naming convention being used here and the way IoT bots are using it, or maybe the attackers are using this naming convention, it looks like these are legit binaries. DNS scan, LDAP scan, and so on. But in fact, these are malicious in nature. So as a result, you look at these binaries initially on the operating system. When you're a bit of scanning, or when you're looking at for your own purpose, you see these binaries look legit, but exactly it is not. So in that case, we cannot rely on the basic naming or the basic structure. We really need to do a little bit more content inspection and understanding how these binaries are interacting with the operating system. So generally, as a part of remembrance, this is a one part where exactly camouflage binaries are distributed across the internet as well. And we really need to see making sure that we differentiate between these binaries when we are analyzing it. Another interesting characteristic, and the way these IoT bots are designed, attackers of course use some sort of packers, making sure that it impacts reverse engineering efforts a bit, but that should not stop you, or there is no way. I mean, if the bot is packed, you cannot unpack it. But interestingly, it actually added another layer of effort to unpack the bot and then making sure that you are able to get the right payloads out of it before you start analyzing it. But that is more important, that you conduct all these steps, making sure that IoT bots or any bot you're specifically analyzing, how it looks like, how the structure looks like, where it's an ELF binary, which architecture it supports, whether it's packed or not. So we really need to see that. And that is a thing we have seen across many IoT bots. In this case, the example highlights a UPX packer, but you can unpack it, but more efforts are needed in that direction. Another interesting scenario that you need to look into, the embedded XParts in the IoT binaries. Remember, these are scripts that are installed in the IoT devices, primarily in the temp directory, because that's where these files are fetched. And what happened in that case, they have embedded payloads. Since most of these IoT devices are somewhat connected to the internet and have a very lower security from configuration perspective, which means the ingress and egress rules are pretty easy in nature. You can connect to anything on the internet depending on its an HTTP traffic and all that, which makes it quite easy and to actually embed the exploits in IoT bots and execute them. So if you look at in this particular example, it's just an exploit related to the Linksys router, but you can see that the bot payload already has HTTP post requests from where they want to do it. So it means attackers are compromising one IoT device and using that IoT device to execute exploits by mass scanning other IoT devices on the internet. So if you find it, you find a particular port that is open, whether it's on HTTP specific or any other protocols, Telnet, RDP and all, you can actually go ahead and you utilize that IoT device that is compromised and then trigger exploits against other known or unknown IoT devices on the internet. So generally, if you have any protection solution in place or detection solution in place, they see that this attack is coming from one specific IoT device, not exactly any other system. So it seems like attackers playing a lot by compromising IoT devices and utilizing one to attack the other. I think that's a part of the chain infection is, and that's how you build IoT botnets, a network of bots. Another interesting tactic that we really need to look into is a self-deletion and removal of stored payloads. So most of the time, what we have seen that in temp directory on these IoT devices, a temporary scripts are being downloaded. And once those scripts are executed in the system, they have a self-deletion module in it, which means they are going to clean the temp directory. And once the payloads are executed, starts opening network communication, channel-wise sockets, and all that, they actually clean the raw binary, which means as a part of the self-deletion to reduce the number of artifacts that are staying on the operating system after the execution, to ensure that when any researchers are coming across any post-execution analysis is performed, they are not able to find most of the content of the payload and all that. I mean, there are still other ways, but you have to dig pretty deep into it. But this picture actually here represents you how an example, if we look into the update or sh file in the temp directory, how it executes command and what exactly it does. And then it actually cleans it. So if you look at the remove -rf, and then it starts cleaning those binaries as well. The next one is executing mass scans. So your IoT device is compromised, and what you want to do with it. Of course, you want to utilize the power and harness the power of that device to trigger more mass scans on the internet so that you find more vulnerable devices and exploit them and make them as a part of the IoT botnet. So these few examples highlight you exactly how the IoT devices compromised in nature are conducting scans against, for example, another Android IoT devices, looking at the TCP port number 5555, which is the Android debug port. and a telnet port on 23 in the second figure. So you can conduct multiple types of scan with that as well. So the next one is looking at the triggering denial of service attacks. So of course, I mean, if you have a network of IoT bots that are communicating between each other and working as a one network, you want to utilize that network to conduct some unexpected scans and launching denial of service attacks that these bots support. So if we have a n number of IoT bots in the network, so you can utilize those n number of bots to trigger dedicated scans on variety of ports utilizing different communication channels. So a few examples that what we highlighted here are taken from the C&C panels directly. So we have you have TCP variety of floods that you can trigger UDP, plain, STD, VSC, OVH, game, stomp, frag, XMS. And you can go for basically an application layer denial of service, as well as you can go for a network layer denial of service, targeting other dedicated resources on the internet. And that is one of the important part. And as everybody who conduct research in this field, they know that denial of service is one of the important functionality these botnets provide. Another interesting thing which I really want to highlight, that a very important one, is the utilizing of the system tools. So when a couple of these scripts are installed on IoT devices, primarily, so because of these IoT devices running Nix version like Linux, some version of other Unix on it, so they are actually have some sort of system tools available by default. Some of them related to, for example, curl utility, wget utility, and for similar things like that. So if you have those utility available in the system and you have a very insecure configuration where you allow to connect anything on the internet, so once you install these scripts, they actually utilize those tools to fetch more binaries on the system, IoT bot payloads, or some BSides kind of libraries if it is not installed on the IoT device, and they actually utilize to automate the process of downloading more infectious tools on the system. But at first, they utilize the system power tools. It means whenever you're analyzing IoT bots, conducting research, you need to make sure you look into the usage of these tools as well. For example, if you're analyzing logs, you want to see that how these tools are being used, where they are connecting to, how long they are connecting to the remote destination on the internet. But this is one of the very important play that these attackers go for it and then conduct nefarious operations, as I discussed earlier, on the internet. But these system tools play a critical role in that as well. So a few examples highlighted here. You can see that BSides are used in conjunction with the wget here. We are having a base64 encoder decoder functionality, Python, and all that. But this is all the part and parcel of the malicious toolkit that these IoT bots use. So now, since we have gone through understanding, why critical IoT threats are and how they exist, and looking into some of the attack techniques and tactics, we really need to look into a few demonstrations here. And the important part is to get a feel of it, how it looks like. So let's go through the first one. In this simple 1-minute demo, what I have exactly highlighting is the internal details of the Verizon IoT botnet C&C panel. And let's take a look into it. So as a part of the research, we are logging back into the C&C panel, which is not active anymore, but we made a video because it was active for like a few hours, but try to highlight how it looks like and how we really need to build intelligence out of it. Using some of the commands here, and you can see that which functionality the C&C provides, what kind of activities can be performed. Yeah. So this is a quick overview how it looks like. And it gives you the idea, the different kind of operation that you can perform from this C&C panel. And just imagine this CNC panel is not a similar for what kind of different botnets that we have analyzed earlier, or we have the world has seen like Zeus, SpyEye, Citadel, and many other like that. Those are much more operated, and the CNC panels are hosted on the as a web resource because they utilize HTTP communication. In this particular case, it is just a custom version that is being deployed on the top of the Telnet protocol, and that's how they actually design these IoT bot CNC panels. Now, in the next video, I'm going to do a detailed look into multiple CNC panels so that you can imagine the design stays the same, but there are many CNC panels that exist in the wild. Earlier, you have seen the Verizon IoT panel. Now I'm going to show you exactly multiple panels and how they look like and the functionalities they provide. So this is an example of the Kavari IoT bot. And just all these panels are now gone. So that's why we are presenting this video. Just try to give you an idea how the real world looks like, how the underground cyber community works. Whatever we are doing on the internet in front is not exactly what is happening in the back end. So this is another example of an IoT bot. Another one. These are like a small botnets, not enough IoT bots residing in it, but still they can do the damage if they want to. And this is an example of the Danknet. Still, they have some bots residing in them. Yeah. So the purpose of showing a quick demo about what the internal structure of CNC panels look like and how different communication channels are utilized, you can get an idea of what kind of research you need to perform down the lane to kind of strengthen your existing security detection and protection solutions so that you can actually deploy those solutions in the real world and prevent these kind of attacks. But in order to do that, we have to really go deep into the understanding the internal architecture of these IoT botnets, how they operate, how these bots are distributed, how they spread infections, and how exactly they create chain infections and related artifacts. So after going to understanding, what IoT threats look like, how exponential these IoT threats are increasing, and going through characteristics and functionalities, and looking at a few demos, I would like to make a call as a part of inference here. Security is not a one-step process. Security is a continuous process. We need a multifaceted approach to build intelligence in order to circumvent and defend against threats in the IoT hemisphere, which means that one approach are not going to work and we will not survive that. We really need multi-step approach, a very deep defense and depth layer mechanisms where every layer is good enough to provide security. And then we actually go for building a strong and a robust protection solutions to defend our internet infrastructure against these nefarious attacks. But at the end of the day, we really need multifaceted approach. So I'll stop by here. Any questions and queries? I hope you enjoy this talk, and I would love to have more discussion on this front. Feel free to ask any queries, and I appreciate all your time and support for attending this talk. Thank you very much.